Hello folks, I am Yashwant Kanetkar and today we propose to understand the intricacies of switch or the case control instruction. These intricacies are important as you go about making use of switch statement within your Java program. Switch ultimately is used to do what? To implement the case control instruction. Now within a switch, there are possibilities that the case may fail or the case may succeed. If a case fails, then I don't have to do anything. Control automatically jumps to the next case. That is the behavior of the case control instruction. As against that, if a case is satisfied, every single statement below that case up to closing brace of switch, they get executed. Any cases or default that it may come across, they would simply be ignored. If I do not want that to happen, then below the set of instructions for that particular case, always employ a break statement. On meeting break, control will come outside the switch. It will terminate the case control instructions execution. Now there is always a possibility that every single case that you have written within a switch fails. If that so happens, the control will jump to the default case provided it has been written within the case control instruction. Since default case is optional, it may not even be present. If it is not present, then control will go completely outside the switch if none of the cases are satisfied. So that possibility always exists. So behavior will be different if default is present as compared to when it is absent. If present and all cases fail, control will jump to the default case. Otherwise, it will go outside the switch if there is no default case. Not having a default case is not a crime. Why? Because default case, as mentioned here, is optional. Lastly and quite importantly, the order in which you write the cases simply does not have any bearing on execution. You may write case 1, case 2, case 3 within a switch, or you may say case 3, case 1, case 2, or case 2, case 3, case 1, or absolutely any other order that you may deem fit. Because ultimately it's going to evaluate it case by case. Whichever case you have written first, that will be evaluated. If that fails, it will jump to the next case. If that fails, it will jump to the next case, so on and so forth. So you have complete liberty in changing the order of the cases inside a switch. Let's now look at some of the subtle issues associated with this case control instruction. Very, very important that it will work only for a char, a byte, a short, int or a long. In fact, byte, short, int and long are nothing but variations of the integer. So apart from integer, it will also work for a char. What are the differences between byte, short, int and long? Byte is 1 byte long, short is 2 bytes long, int is 4 bytes long and long is 8 bytes long. But basically all of them can hold what? Only integer values. Means for integers and char alone the switch would work. Do not try to make use of switch for float or a double. Means tomorrow don't say switch A and then case 1.5, case 2.5, case 3.5, case 4.5. That's not going to fly. You cannot check against float values, you cannot check against double values. Then what if I am genuinely interested in checking against float values? Well, who prevents you from using if? You can always say if A is equal to 1.5, if A is equal to 2.5. With if else there is no such restriction. It's only with switch such a restriction exists that you can never check floats or doubles using a switch. Thirdly, even for a moment, don't believe that switch is a replacement for if. No. If is much more versatile. If can check whether A contains 1.5, 2.5, 3.5. It can also check whether A contains 10, 20, 30. It can also be used to check ranges. I can say if CH is less than equal to 60 or CH is greater than equal to 75. So I can write multiple conditions, combine them using OR, AND, etc. All of that is not something that you make use of in case of a switch. Switch is basically used to do what? To check whether value of a variable is one value, another value, yet another value, some other value. Specific values when you are required to check against, go for a switch. That's a better idea as compared to using if and else. Now, if there is a logic which can be implemented using if, it can also be implemented using switch. Question comes, which one should you prefer? Well, switch is likely to work faster than if. Why? Because switch is always implemented using what is known as a jump table. When you compile a program which uses a switch, a jump table is created in memory. That jump table contains what? It contains information that if value of a variable is this value, straightway jump to this particular address where the instruction for that particular value of switch or that particular value of case is kept in memory. For another value of variable that you are checking in switch, there is another jump instruction to which address should the control jump if that value is encountered in the switch variable. Since it is jump table based, it is very easy to do what? Jump to that particular instruction during execution. As against that, if you make use of if and else, the conditions of if and else are evaluated at runtime. So time will be wasted in doing this. Especially if the big instructions are there, big conditions combined using and or operators. If that is what you have used, all these conditions would be evaluated at execution time. In that sense, you should always go for a switch because that's likely to run faster than corresponding if and else. Choice of course is yours. You can implement the logic using switch. You can also do so using if else, or you can make use of nested if else's. Any of these three options are available at your disposal. Traditionally, people have been using switch whenever they are to check a variable's value against 4, 5, 6 specific values. That's when you go for a switch. So much about the case control instruction subtleties. Goodbye and good luck.